Hi, I am Sanjay Patel. In this lecture, we are going to derive the equation of plane of contact of a sphere. Let us understand the term plane of contact. Remember that this is not same as the tangent plane. So let us understand what is the plane of contact. But before I explain this by figure, let me write down the meaning or definition of plane of contact. Say, let capital A be any point in the exterior of a sphere capital S. That means the point A is not lying on the sphere, it is outside of the sphere. Okay. Now, you can imagine that you can draw infinitely many planes which are passing through the point A and touching the sphere S. Say something like this. Suppose this is a sphere and a point here is in the exterior, then you can draw a tangent plane passing through A and touching to the sphere. This point is in the exterior. So we are talking about this tangent plane. So let A be any point in the exterior of sphere S. Okay. Then there are infinitely many tangent planes of the sphere S which passes through the point A, the exterior point A. Okay, and since all the tangent planes, so we can draw another tangent plane like this. Okay, it is also passing through and it's touching here somewhere. This is also touching here. This P and Q, etc., all such points are the point of contacts of these different tangent planes to the sphere, and all the tangent planes are passing through it. All such points, if you collect on the sphere, which are point of contacts of different tangent planes, then these all are lying on some plane, and this particular plane on which all the point of contacts lie is known as the plane of contact. So let me write the definition now. A is any point in the exterior of a sphere, and we have infinitely many tangent planes of the sphere S which passes through the point A. Then the point of contacts of these tangent planes, the point of contact of these tangent planes lie on some plane pi. Okay, and this plane pi is called the plane of contact of the sphere S with respect to the exterior point capital A. Okay, to understand this let me now give you a nice simple figure. say I already made it. So this is the figure. A sphere is given, and this ax0, y0, z0 is in the exterior of the sphere. Then we can draw many planes which are tangent to the sphere and passing through A. I have shown two such planes. This is one plane and this is another plane. You can draw infinitely many tangent planes which are passing through the point in the exterior. These are the tangent planes to the sphere, so they are touching the sphere at some point. So the first plane is touching here, the second plane is touching over here. So these are the point of contacts. And if you collect all such point of contacts, then lie on some particular plane. And that particular plane is here shown by the blue color, and that is called plane of contact. Okay. And we want to derive the equation of plane of contact for a sphere. So let us write down the statement of a theorem. This concept is a little bit mathy. Say, let me write down the statement. Obtain the equation of the plane of contact. Obtain the equation of the plane of contact of a sphere, say x given by x square plus y square plus z square plus 2ux plus 2by plus 2wz plus d equal to 0. I am taking the general equation. So obtain the equation of the plane of contact of a sphere with respect to an exterior point. Say A, x0, y0, z0. Okay. Let us prove this. So I will be starting in this manner. Say let or suppose, let me write like this. Suppose a tangent plane to the given sphere, capital S, which is passing through the point capital A, x0, y0, z0, okay, touches the sphere at a point say p alpha beta gamma. Okay, so let us understand this. So a sphere is given and a point outside of is given. This is a sphere and a point here A is given in the exterior, which is x0, y0, z0. what we have written here is, suppose a tangent plane to the given sphere S, which is passing through this. So we consider a tangent plane to the sphere which is passing through the point A, x0, y0, z0. Okay. Fine. And this tangent plane is touching the sphere at some point P, alpha, beta, gamma. So this P is a plane of contact. And remember, this is a tangent plane to the sphere. Tangent plane to the sphere. And for a sphere which is in the form x square plus y square plus z square is equal plus 2ux and so on, we know the equation of tangent plane at any point alpha, beta, gamma on it. So I can write the equation, therefore, the equation of tangent plane, equation of this tangent plane to the sphere S at the point P, alpha, beta, gamma is given by, we know that the equation alpha plus u into x plus beta plus v into y plus gamma plus w into z plus alpha u plus beta v plus gamma w plus d equal to 0. Okay. This is the equation of tangent plane, this tangent plane, okay, to the sphere at the point P, alpha, beta, gamma, which we have derived in our earlier lectures. Okay. And this tangent plane is passing through the point A, x0, y0, z0. So this point satisfies this equation. So I can put x equal to x0, y equal to y0 and z equal to z0. So let us write down that fact. Since the plane 1 passes through the point A, x0, y0, z0, we get alpha plus u into x0 plus beta plus v into y0 plus gamma plus w into z0 plus alpha u plus beta v plus gamma w plus d equal to 0. Okay. So what I have proved actually, I have proved that if plane, I mean the point P, alpha, beta, gamma, it satisfies this equation, or let me write in a different way. This means so this implies, I can say, the point P, alpha, beta, gamma satisfies the equation x plus u into x0 plus y plus v into y0 plus z plus w into z0 plus say u into x plus v into y plus w into z plus d equal to 0. Okay. This alpha, beta, gamma, wherever is there, we are just replacing it by x, y, z. So I can say that P alpha, beta, gamma satisfies this new equation. But what is P alpha, beta, gamma? P alpha, beta, gamma is the point of contact. The point of contact. It is this point. And we know that all such point of contacts which are lying on this sphere, they are passing through, the plane passing through all such point of contact is our plane of contact. So this plane of contact is actually given by this equation. So let me, you know that this equation is nothing but a equation of a plane. So I can say the locus, therefore, equation 3 says that the locus means the path of points, locus of points of the form, or say of the type P alpha beta gamma satisfies equation 3 says the locus of points of the type P alpha beta gamma satisfies equation 3. Okay, I can say from this that it satisfies the equation 3. So and this equation is an equation of a plane. This equation is an equation of a plane. This equation 3 is an equation of plane, and all the point of contacts satisfies the equation 3. It follows from equation 3. Equation 3 says means it follows from this equation that all the points of the type P alpha beta gamma satisfies the equation 3, and this equation is the equation of plane, and therefore I can say that all the point of contacts of the sphere corresponding to different tangent planes from the exterior point lies on this plane, and therefore equation 3 is the required equation of plane of contact. Required equation of plane of contact. So just we have to rewrite the equation in a nice way so that you can get an interesting result. Equation 3 can be written as, equation 3 can be written as, by collecting the terms like say x first. So x is here and also it is here. So collecting all terms containing the variable x, I can write this as say x0 plus u into x, collecting terms containing y, that is this and this. So we get y0 plus v into y. Same way we get z0. If you collect terms containing z, so you will get z0. There are these terms. One is this, other is this z. So we'll get z0 plus, not z, z0 plus w into z, okay, and plus all the remaining terms. So plus x0 into say u plus y0 into v plus z0 into say w plus d. These are the remaining terms. This is equal to 0. Okay, and it is actually something like not something like, exactly like the equation of tangent plane to the sphere. Okay, do you remember? It is the same as equation of tangent plane. So only difference here is this x0, y0, z0 is not a point on the sphere. It is an exterior point. Okay, so it is easy to remember. So I can replace this x0, y0, z0 by alpha, beta, gamma also, and write in the same manner as we have studied the equation of tangent plane. Okay, so this is the required equation, which is the required equation of plane of contact. Plane of contact of the sphere S with respect to the exterior point A x0, y0, z0. So you can remember this, and it is not difficult to remember. It is same as the equation of tangent plane of a sphere for the general equation, and you know, there we have alpha, beta, gamma in place of x0, y0, z0, and equation is exactly same. Okay, and as a corollary to this result, I can write the equation of plane of contact for the standard equation of the sphere. So let me write this way: the equation of plane of contact of a sphere S given by x square plus y square plus z square is equal to a square from an exterior point capital A x0, y0, z0 is given by we'll get x0 into x plus y0 into y plus z0 into z is equal to a square. How? It is very simple. Since we have the general equation, just I am giving you a hint. We have the center in this case minus u minus v minus w is equal to 0, 0, 0. Okay, and the radius r is equal to a. Okay, so just substitute say uw equal to 0, 0, 0. Okay, so all this will go and you will be left with this d. But what is d? D is the constant term, and that is also, yes, d is the constant term. And how we can get the radius there? I can add d is equal to say minus a square. D is equal to minus a square in that equation. Or you can say directly we have this relation, you know, a is equal to square root of u square plus v square plus w square minus d, correct? So a square, since u, v, w are 0, is equal to d. A square is equal to a square is equal to minus d. Okay, so that gives you d is equal to minus a square, and that you have to substitute in this result. Just d is equal to minus a square. U, v, w are 0, so you will get finally the equation of plane of contact like this. Okay, so this is about plane of contact, and let us take one simple example as an application of this. Okay. If the plane of contact of a sphere x square plus y square plus z square is equal to 4 with respect to an exterior point, capital A is 2x minus y plus 2z is equal to 4. Then find the coordinates of the point A, of the exterior point A. Okay. So understand this problem. If a plane of contact of a sphere x square plus y square plus z square is equal to a square. So suppose the point A is x0, y0, z0, which is an exterior point. This is an exterior point. Okay. Then the equation of plane of contact, is, we know it is x0 into x plus y0 into y plus z0 into z is equal to a square, because this is our standard equation. So that I can write as x0 into x, y0 into y, and z0 into z. So x0 into x plus y0 into y plus z0 into z is equal to 4, because a square is equal to 4. I don't know what is x0, y0, z0, and x, y, z are variables. So let us call this as result number 1. Okay, but we are given that the plane of contact for the sphere x square plus y square plus z square is equal to 4. Okay, is this. So what can I write here is, but the plane of contact with respect to A of the sphere S is 2x minus y plus 2z is equal to 4. Okay, so that means the plane 1 and 2, or equation 1 and 2 represents the same plane. 1 and 2 represents same plane. So therefore 1 and 2 represent the same plane. Okay, so we can compare the coefficients. Therefore I can compare the coefficients. So comparing the coefficients of 1 and 2, we get this thing, x0, coefficient of x in equation 1 divided by coefficient of x in 2 is equal to y0 upon minus 1 is equal to z0 upon 2, and that is equal to 4 upon 4 means 1. Okay, so that gives you x0 is equal to 2, y0 is equal to minus 1, and z0 is equal to 2. Okay, so that gives you the coordinates of the exterior point. So therefore the exterior point is given by x0, y0, z0, that is 2, minus 1 and 2. So this way you can solve such problems. Okay, so thank you.